Now we're going to look at using proportional relationships for real-world applications that involve geometry. One of the real-world application that uses a lot of geometry is scale drawings. You can see a floor plan for a house, and the floor plan better looks similar to what you get when you build the house, otherwise there's a problem. In this, you have this large room, it should definitely be bigger compared to this smaller room. Any distance here represents an actual number of feet of that wall for that house. Another application is maps. So here I have a map of northern Spain, which shows the hike that I did this past summer. And every little unit of distance represents the actual height. In fact, this is for a biker, and so they're probably going about 50 miles a day, depending on how many mountains there are. Speaking of mountains, here's another scale drawing that shows the elevations of how high you're climbing up or going down on any given stage of the hike. So a scale drawing is a drawing that uses a scale ratio to represent an object as smaller or larger than the original object. In example 1, we're looking at a scale drawing of a garden. Esmeralda drew this for the community center, and each of the squares is 1 centimeter by 1 centimeter. She was using grid paper. She used a scale that every 2 centimeters should be 5 feet. So the first question is, what is the perimeter of the garden, the dark border here, in centimeters on her drawing? Well, I just went ahead and counted all of the centimeters, and I have 8, 16, 8, and 16. To get the perimeter, you just add the distances around, and for this problem, it's 48 centimeters. Then the next question asks, how many feet of fence will she need to enclose the real garden? Well, it's not 48 centimeters, that's less than a meter. I have to convert these measurements to the actual fence measurements for the garden. So the first one I'm going to say, if I count the garden, I have 8 centimeters, and I'm trying to find out how many feet 8 centimeters is. Well, I do have the ratio, the scale here, which is 2 centimeters and 5 feet. You can, here I kind of use 6th grade math, and I said, aha, I can go backwards and say I have to multiply by 4 to get from 2 to 8, and then if I do that to 5, that tells me that x has to be 20. Now I also want to find this longer distance, 16 centimeters, and find out how many feet that is. Again, you can do the same thing, and you could figure out 8 times 5. But you could also cross multiply it. You can say 2 times y equals 5 times 16. Well, 5 times 16 is 80. If 2y is 80, then y is 40 feet. They wanted the dimensions, so I went ahead, they wanted the perimeter of actual fence, so I have to go and add the 20 feet plus the 40 feet plus the 20 feet plus the 40 feet, and I need 120 feet of fencing for the garden. The next question is, what are the dimensions in the drawing for the lettuce? And by that I mean the lettuce part of the garden. If you count here, there are 2 centimeters, and counting this way, it's 6 centimeters. So it's very simple. 2 centimeters by 6 centimeters. Then finally, we want to convert this to the actual dimensions in feet of how big the lettuce part of the garden will be. Well, it's still 2 centimeters, and I set up a proportion. 2 centimeters to the actual width in feet is the same as 2 centimeters to 5 feet. This comes from the scale that I was using earlier. Well, since they're both 2 centimeters on top, W better be 5. So in this case, the width actually is 5 feet. Now we want to find the height, this length. So I say 6 centimeters, which is the measurement for the length there, to the actual length in feet has to equal the scale. So you see I have centimeters to centimeters, feet to feet, and this is my drawing to my scale. Cross multiplying, I get 2 times L equals 5 times 6, or 2L equals 30. Divide both sides by 2, and the length is 15 feet. They ask for the dimensions, so I say the dimensions are 5 feet by 15 feet. In example 2, Victoria is making a scale model of her dorm room at college so she can figure out what furniture she can take. Her dorm room is 10 feet wide by 12 feet long, and in her drawing, the length of the room is 16 centimeters. So she's already started to draw her room. And the question is, what scale did she use? Well, I want to compare apples to apples. I want to go length to length, not the length to width, but length to length. So I know I have a length of 12 feet here in real life, and in her drawing the length is 16 centimeters. Well, I just make a ratio from those two and simplify it. It's 4 centimeters to 3 feet, or 4 centimeters to 3 feet. I wrote it with a colon here instead of fraction notation. Now the question is, how wide is her room on her drawing to the nearest tenth of a centimeter? The width in real life is 10 feet. So I'm trying to find the width in the drawing. So it's 10 feet to X centimeters, that's the drawing. See, real life drawing width is to the scale, 3 feet to 4 centimeters. My labels match here, and my labels match across on the top for the feet. Then cross multiply, 4 times 10 equals 3 times X. Then I can solve it for X, and I find out that X is 13.3 centimeters. And I should have written the centimeters on there. In fact, let me do that. It's good to write the units anytime you have them, so that should be centimeters. Now, indirect measurement is another application that we have besides scale drawings. Scale drawings are a form of indirect measurement. So indirect measurement is using something else like a shadow or a geometric relationship to figure out what a measurement might be, because you can't actually go and measure it. In this example on the top right, I have a lighthouse and a person standing. Well, we can figure out the height of the person pretty easily. And what we're going to look at, we're going to use their shadows. The reason we do that is the sun is so far away that the angle it creates with the object or the people is the same. And since the people are standing straight up and the object standing straight up, we actually have right angles there. So I could actually mark this angle is congruent. It's a right angle. I should do a little square. That's a right angle right there. And this is a right angle. And since the sun's so far away, this is congruent to that. So I have angle-angle similarity for shadows. And what you can do is you can measure this person's height compared to their shadow and set up a proportion to find the lighthouse height compared to its shadow. Another thing you can do, which is kind of cool, is use a mirror. You can place a mirror so that you can see the top of something in the mirror at a certain distance away. And that, because the mirror has the same angle when you're looking at the light, it comes off, it comes in and comes out at the same angle. Those two angles are congruent. Then since the person is standing, that's a right angle, and the lighthouse is also a right angle. That tells me two angles are congruent, so these are similar triangles. So an indirect measurement, it's any method that you can use. It doesn't have to be shadows. It can be formulas, similar figures, and or proportions to measure an object. Now let's use indirect measurement to measure the height of a light pole. It's very difficult to go up and measure a light pole, so we're going to use shadows to do this. Jenny is 5 foot 2 inches tall. Her shadow is 7 feet 9 inches tall. And the pole we're trying to find, I went ahead and put an X next to it. And the shadow from the pole is 15.5 feet. The first step is I have kind of mixed units in here. I have completely feet and feet in inches and feet in inches. So I need to convert them all. The first one's easy. I just multiply it by 12. The second one, I take the feet, multiply it by 12, and add in the 2 inches to get 62. And I do the same thing for the shadow. 7 times 12 plus 9 is 84 plus 9, or 93 inches. Now I'm going to set up a proportion so that I can figure out the relationship between height and shadow and height and shadow. So setting up my proportion, I could say that X is to 186 as 62 is to 93. Once the proportion is set up, I can cross multiply, so I get 93 times X equals 62 times 186. There could have been some simplifying done, but since we're allowed the calculator, I'm going to leave the numbers as they are. Then divide both sides by 93 to solve for X, and your calculator tells you it's 124 inches, and if you looked at it, you'd say, oh, there's 10 feet in there, 10 feet, 4 inches.